Prepare to be amazed. NASA and its European partners are on the verge of launching Sentinel-6B, a groundbreaking satellite poised to revolutionize how we track our planet's oceans. This mission is critical, as it aims to monitor sea levels across over 90% of Earth's vast oceans. But what exactly does this mission entail, and why is it so important? Let's dive in. Sentinel-6B, a collaborative effort between NASA and the European Space Agency, ESA, is ready for liftoff, snugly packed within a SpaceX Falcon 9 rocket. The launch is scheduled for November 17th at 12:21 a.m. Eastern Standard Time, or November 16th at 9:21 p.m. Pacific Standard Time. The launch sequence will last for 57 minutes, culminating in the satellite separation from the rocket. Once in orbit, Sentinel-6B will begin its primary mission. It will circle Earth every 112 minutes at a speed of 4.5 miles, 7.2 kilometers per second. This satellite will eventually take over from its twin, Sentinel-6 Michael Freilich, which was launched 5 years ago. The mission aims to continue a decades-long data set of sea level measurements from space. This data is crucial for improving public safety, urban planning, and protecting coastal infrastructure, including power plants and defense interests. Furthermore, NASA will use the data to refine atmospheric models, supporting the safe reentry of Artemis astronauts. This is a crucial element of the mission, but it's often overlooked. Let's get into the specifics. The satellite is 19.1 feet, 5.82 meters, long and 7.74 feet, 2.36 meters, high, including its antennas, weighing approximately 2,600 pounds, 1,200 kilograms, when fueled at launch. The launch will occur from Space Launch Complex 4 East at Vandenberg Space Force Base. If needed, backup launch opportunities are available on subsequent days, with a launch window shifting by about 12 to 13 minutes earlier each day. Here's a glimpse of the launch sequence. Just over 2 minutes after liftoff, the main engine will shut down. The first and second stages of the rocket will then separate, followed by the second stage engine ignition. The reusable Falcon 9 first stage will then execute an automated boost back burn to return to the launch site for a powered landing. About 3 minutes after launch, the payload fairing, which protected the satellite during its journey through the atmosphere, will separate and return to Earth. The second stage engine will cut off for the first time approximately 8 minutes after liftoff, placing the launch vehicle and spacecraft in a temporary parking orbit. The second stage engine will fire a second time about 44 minutes later, and about 57 minutes after liftoff, the rocket and spacecraft will separate. About 7 minutes later, the satellite's solar panels will deploy. Sentinel-6B is expected to make its first contact with ground controllers about 35 minutes after separation, approximately an hour and a half after liftoff. A significant milestone indicating the spacecraft is functioning correctly. After launch, the team will focus on preparing the spacecraft for scientific operations. Once in orbit, Sentinel-6B will trail its twin, the Sentinel-6 Michael Freilich satellite, by about 30 seconds. Once scientists and engineers have cross-calibrated the data collected by both spacecraft, Sentinel-6B will take over primary sea level measurements, while Sentinel-6 Michael Freilich will be repositioned for other research purposes, including mapping seafloor features. But here's where it gets controversial. Some scientists argue that the data from these satellites could be used to better understand the impact of climate change on coastal erosion and flooding. What do you think? Live coverage of the mission will be available on NASA's website beginning no earlier than 11 p.m. Eastern Standard Time, November 16th, including live streaming and blog updates. Streaming video and photos of the launch will be available shortly after liftoff. Follow the countdown on NASA's Sentinel-6B blog. The Copernicus Sentinel-6/Jason CS mission is a collaboration between NASA, ESA, EUMETSAT, European Organization for the Exploitation of Meteorological Satellites, and the National Oceanic and Atmospheric Administration, NOAA. The European Commission provided funding, and France's space agency NEAS provided technical expertise. This mission also marks the first international involvement in Copernicus, the European Union's Earth observation program. JPL, a division of Caltech in Pasadena, built 3 science instruments for each Sentinel-6 satellite: the Advanced Microwave Radiometer, the Global Navigation Satellite System, radio occultation, and a laser retroreflector array. NASA is also contributing launch services, ground systems to support the NASA Science Instruments, the science data processors for 2 of these instruments, and support for the U.S. members of the International Ocean Surface Topography and Sentinel-6 science teams. The launch service is managed by NASA's Launch Services Program, based at the agency's Kennedy Space Center in Florida. So, what are your thoughts on this incredible mission? Do you believe it will significantly contribute to our understanding of sea level changes? Share your opinions in the comments below.